This is Mehranullah along with my partner Zishan Ali. Our final year project is HVAC calculation and simulation of Sakkar IBA University using Careers HAP hourly analysis program. This project is supervised by Engineer Shakil Ahmed and co-supervised by Engineer Kasir Ali. Now, coming to the introduction, first of all, we did walkthrough audit in which we inspect each building, all the spaces in which we collected data of each space like area of a room, windows area and number of windows, number of doors, and all the heating sources which can contribute to the British thermal unit, which can contribute to the heat. So then we did the manual calculation for each space. For our ease, we create an Excel calculator for this calculation according to HRI standards. Now to the main part, we did career HAP, we designed the HVAC system is per the career HAP simulation in which we insert, input all the data collected from each of the space. Then we get the design report for our HVAC system. Also, we worked on the lighting doors or illuminance as we got and comment in our first evolution. So we did work on the illumination using lux meter. And finally, our last result was to compare these all calculation, all results. So we did comparative analysis of manual, installed, and simulation software design system. Now, problem statement. Building consumes more than 1/3 of world's primary energy, of which about 1/3 is consumed by HVAC, heating, ventilation, and air conditioning system. We know that heating, ventilation, and air conditioning system provides comfort to our life, at offices, at our rooms, at our educational facility, but it can be, we can make it better and economical. So we are working on to make HVAC system of Sakkar Highway economical and better. And one of the problem is that in Pakistan, mostly standards are not followed. So we are designing this HVAC system for Sakkar Highway as per international system, as per HRI standards. Objectives. Our objectives are determine and analyze our load loss and gain for the academic blocks of Sakkar IBA, determine and evaluate the energy demand of Sakkar academic block using career HAP simulation program, reducing energy bills by designing HVAC and lighting is per international standards, managing energy consumption and energy conservation for future. Literature review. We followed certain research paper for our work. Mainly, we followed HAP software manual and HRI standard fundamental books, but there are certain research papers through which we studied for our research, like cooling load estimation for multi-story commercial building using HAP. In this paper, the author worked in same way as ours. They used HAP software for multi-story commercial building and they designed HVAC system. Audit and analysis of energy utilization in engineering institution buildings. In this paper, the difference is that the author used ETAP software and their main focus was on energy audit and analysis further of engineering institution building. And this comparison between hand calculation and HAP program for estimating total cooling loads for building. We also did same work like this. We did manual calculation and also we designed our HVAC system for Sakkar IBA through simulation program, hourly analysis program, and we compared these results at last. Design of air conditioning system by using HAP. In this paper, they designed the air conditioning system by using our analysis program. In this study and evaluate the technical designing of heating, ventilation, and air conditioning system for commercial high-rise building. Methodology. There are mainly three parts of our work. First of all, we did walkthrough audit, which include building survey, inspection, manual calculation, And then we worked on modeling and simulation of HVAC system using carrier HAP software. We also worked on lighting load elimination using lux meter. Now coming to our work, first of all, we did walkthrough audit. So of all the academic block 1, 2, 3, and 5, this 5 block is under construction. So we designed an estimated design HVAC system for this block, and we compared the result of these 3 blocks with the installed one. This is the data which we collected for all the buildings, for all the spaces. Like for 101, this is the area of the room for 42, and number of doors is 1 door area, number of windows we get for all the room like this. This is data is for block 3, and this one shows block 2 ground floor. These are the spaces, room numbers, and these are the room area, number of doors, door area, and all the data is previous. This is the data for block 1, first floor, and this one is the block 5, ground floor. These are the spaces, different rooms, and these are the area, number of windows, and window area. Now, this is our main work start here. We did the manual calculation according to HRI standard. We used certain formulas, and we created an Excel calculator is shown in this figure. Cooling load calculation of Sakkara University. In this window shows Windows BTU. We got Windows BTU from this window is here. Windows BTU shows 161464. The windows quantity are 4, length and width, area, and we got BTU here. Is also the same process for roads and room area calculation and lighting details, number of person or occupancy, we can say these all contribute to the total BTU for a room. So we sum the here and then convert it into ton. So we get the required cooling system and turn for a room. Now, result in discussion. Here we discuss the result we got from the manual calculation. This figure shows the cooling loads required in turn for block 3 as per our manual calculation. So for each room, this shows for room 1 of block 3, 1.58 turn, for room 2, 0.5, for 3, 0.6, and also for each floor, this shows different cooling system in turn. This figure shows for block 1 and for each room, first floor and ground floor. This one shows for the block 2, ground floor, first floor. Now this is our lighting loads calculation. In this work we did, we calculated lux at working level for using lux meter. Lux meter is a device which measured lux at certain space, and this column shows the standard lux at working level. And this is different for each room is per the usage of room. Classroom and offices and computer lab with different lux is per standard. So we compared these and analyzed this to check whether the lighting load, whether the luminance is per standard or not in Sakkar IBA. We did for each space. Here we shows for 2 floor. This is for ground floor, each room, and this is for first floor. Here's software work. Now we are coming to our main simulation work. So we use in our analysis program version 4.9 North American edition. Here, first of all, we created different project library. Project libraries is schedule, walls, roofs, windows, doors, shades, and schedule. We created schedule as per the school time or as per the university classes time. And then in walls we put data as per the material used in the walls to know the radiation coming to the through these walls to the rooms, and roof area and material, and how much radiation are coming through the roofs. Also we put data about the windows and doors then we put data about the weather. So we did put the data of sucker manually, the average data of each month and each hour to get the exact HVAC system. Then we did put the main entries of spaces of rooms. Like for each room, we put different data like number of doors and their areas and all the heating sources and the radiation coming through the walls. Then we created systems and plants. Then we create the simulation reports. So we got here different reports, like this one is for block 3 first floor. Here we can see that air system name first floor, we named it, and calculation month are from January to December, and sizing data shows it calculated. So this is our main result, like total coil load. It shows us the 20.4 tons is required to remove the heat from air. And this one shows the central heating coil required maximum coil load is 60.2 MBH, and actual maximum max CFM required is 5602 CFM. CFM per person is 15.05 here. This table shows for this first floor, which we named as zone 1, each room, for each room it shows different calculation, different data like cooling sensible, time of load, airflow, heating load, floor area, and CFMs per space. This is the design report for academic block, which block 1, which we got through this software. Here it shows the total coil load required is 46.1 tons, and central heating coil sizing data is 103.2, and supply fan sizing data is 103,930 CFM, and CFM per person is 8.84 here. Now this report shows design report for the academic block 2. Here total coil load is 35.3 tons. Actual maximum coil load is 89.3 MBH. Design airflow CFM is 3035 CFM, and CFM per person is 8.43. This report is for block 5. Here total coil load is 240.4. Here we did this report shows it for all the 4 floors of academic block 5, and this one is the estimated one. Actual maximum CFM at September is 53196, and CFM per person is 10.78. Now here we did comparative analysis of our manual calculation, HVAC design system through simulation, and with the installed system of Sucker IBA. So this color shows that the installed cooling system at Sucker IBA, and this one shows manual calculated system, and this one shows the HAP designed simulation system. Now this here for block 2, this color shows manual calculated, this one installed cooling system, and this one is our HAP designed system. So it is clear from here that the installed system is far greater than the our HAP designed system. Also here it shows that the installed system, which is that one, is greater than the manual calculated or HAP designed system, which are both are as per SI standards. One is through manual calculation and one is through simulation software. So we conclude after that comparative analysis that the cooling system can be reduced to save the monthly bills, to save monthly energy bills. The HVAC system is being determined and evaluated of Sucker IB academic blocks using career HAP simulation program, which can be very effective in order to reduce energy bill by designing HVAC and lighting as per international standards. In future recommendation, we recommend to use any other simulation softwares like ETAP two for more precise and accurate and more comparative HV calculation and simulation system. These are the references we followed to work on this project. And thank you. This was all about our project.